Let's get started with section 1.1, linear equations. We're going to look at basic terminology of equations, linear equations, identities, conditional equations, and contradictions. We'll also solve for specific variables of literal equations. The first concept that we have to understand is that for equations, we can add or subtract any value we want to both sides, and the solution does not change. In this case, I can add or subtract c to both sides of an equation, and it won't change the value of our solution. Also, I can multiply the left and right side of an equation by any non-zero constant that I want, and the solution will still remain the same. I can multiply both sides by any constant I want, and the solution will still be the same. Let's look at example 1. We have to solve 3 times the quantity 2x minus 4 equals 7 minus the quantity x plus 5. You're always welcome to pause the video and try any of these questions on your own. That's what I recommend you do after we finish the problem or before we try the problem. I'm going to start by distributing the 3 through the parentheses, and we'll distribute this negative here in front of the parentheses. We'll pretend there's an invisible negative 1. So we'll distribute that through the right side of the parentheses. This gives us 3 times 2x, which is just 6x. 3 times negative 4 is negative 12, and this is equal to 7. We'll distribute the negative throughout. That gives us negative x and negative 5. Now the next step is to collect like terms. On the left side I can't add anything together, but on the right you notice there is a 7 and a 5. Let's add those two terms together. So we have 6x minus 12 equals 2 minus x. Now we simplify both sides. I can start adding or subtracting terms to both sides. I want to get the x by itself, so let's add x to both sides. We'll add x to both sides. As a result, we have 7x minus 12 equals 2. The negative x and x cancels out, and now we can add 12 to both sides. So add 12 to both sides. 7x is now equal to 14. Now I can divide both sides by 7. And we have x is equal to 2. That is our solution for the problem. You're always welcome to check your work anytime you want. You can plug this 2 back into the original equation for each of the x's and confirm that both sides are in fact equal after you simplify. So definitely check that work on your own to make sure x equals 2 is a good solution. Example 2, we want to solve 2x plus 4 divided by 3 plus 1/2 x equals 1/4 x minus 7/3. Now this looks like a complicated question, but you can simplify it by looking for the lowest common denominator. If I look at 3, 2, 4, 3, I'm looking for a number that's divisible by all of the denominators, and in that case we have the LCD is 12. I know 3, 2, 4, and 3 will all divide into 12, so that's a good choice for the lowest common denominator. What I'm going to do next is I'm going to multiply that 12 to each and every single one of these terms. I'm going to multiply 12 times the first term, 2x plus 4 over 3. Going to multiply 12 times 1/2 x. We're going to multiply 12 times 1/4 x. And there's a negative here, so we have a couple options. We could put a plus 12 in the front, or we can say we're multiplying by negative 12 instead, which is equivalent. That's what I'm going to do. I'm going to multiply by negative 12 times 7/3. Now it's up to you if you want to put the negative on the inside, then you'll have to change this to a plus. If you leave the negative on the outside, make sure the inside is a plus. So let's see what simplifies. We have the 3 reduces with the 12, making that a 4. The 2 reduces with the 12, making that a 6. 4 reduces with 12, making this a 3. And the 3 reduces to a 1, and this 12 reduces to a 4. Now that's the beauty behind the LCD. It can be used to get rid of all these fractions. So I'm going to distribute now. We have 4 times 2x plus 4, which we will distribute later. We have 6 times 1x, which gives us 6x. We have 3 times 1/4 x, which gives us 3x. Negative 4 times 7 gives us negative 28. Now I can distribute this 4 to the parentheses. We have 8x plus 16 plus 6x is equal to 3x minus 28. I want to collect like terms. Let's add the 8x and the 6x together. That gives us 14x plus 16 equals 3x minus 28. Let's subtract the 3x to both sides. And to save some time, we can also subtract 16 to both sides. Remember, the goal is to get the x on one side and the numbers on the other side. This is going to cancel out the 3x and the negative 3x. The 16 and the negative 16 goes away. So let's see what that simplifies to. We have 11x is now equal to negative 44, and now I could divide both sides by 11. Dividing both sides by 11, we have x equals negative 4, and we can always check our work, making sure that this is a good solution, plugging it into these x's up here, and we'll be able to check our work pretty easily if we had a calculator. An equation satisfied by every number that is a meaningful replacement for the variable is an identity. Consider this example. We have 3 times the quantity x plus 1 equals 3x plus 3. If I were to solve this, I get 3x plus 3 equals 3x plus 3. Both sides are the same. That means that no matter what I plug on the left side, it's going to be equal to the number on the right side. And if I were to continue to solve this, I would have to subtract the 3 to both sides, subtract the 3x to both sides, and we get 0 equals 0. This is always true. This is known as an identity because it is always true. No matter what I plug in for the solution, it's always a good solution. This problem has infinite solutions. In general, we'll say the solution set is all real numbers or simply all reals. An equation that is satisfied by some number but not others is a conditional equation. Consider 2x plus 4. If I were to solve this, I get x equals 2. There is only one solution in this question, and no other solution will work, and that's known as a conditional equation. An equation that has no solution is a contradiction. Let's consider this, where we have x equals x plus 1. If you were to try to solve it, you would subtract x to both sides, and 0 equals 1. This is a false statement. This is not true at all. It is known as a contradiction. In this case, we would say the solution is no solution, or we could write out the symbol for no solution as a circle with a dash through it. This is the symbol for no solution. Example 3, determine whether each equation is an identity, a conditional equation, or a contradiction. The only way to do that is to actually try to solve the equation. If you get a true statement that's always true, then it's an identity. If you get one solution, it's a conditional equation. If you get something that's totally false, that's known as a contradiction. So let's start by distributing the negative 2 throughout the parentheses. This is negative 2x minus 8 plus 3x equals x minus 8. I'm going to start by collecting like terms on the left side. I can add negative 2x and 3x together. This results in x minus 8 equals x minus 8. And notice right away that we do get a situation where the left and right side are the same, exactly the same. So we can say right away that this is an identity. If I were to go further, I would get 0 equals 0. If I subtract x to both sides, add 8 to both sides, I would definitely get 0 equals 0. Therefore, our solution set is all real numbers. In part B, I am going to solve this equation for x just like before. Let's add 4 to both sides. And we have 5x equals 15. Divide both sides by 5. X is now equal to 3. And since this is only one solution, we're going to consider this a conditional equation. Only one solution works. It's a conditional equation. Part C, we have 3 times the quantity 3x minus 1 equals 9x plus 7. As always, let's start by distributing throughout the parentheses. We're going to multiply 3 to 3x and 3 to negative 1. This gives us 9x minus 3 equals 9x plus 7. I'm going to subtract the 9x to both sides because I want to get the x on one side of the equation. We'll subtract 9x to both sides, and something suspicious happens. The 9x and the 9x on both sides cancels out. This leaves us with negative 3 equals 7, and that's not equal. That's false. That's not true. Negative 3 is not equal to 7, so this is a contradiction. This is a contradiction. Therefore, we have no solution. So let's review. If solving a linear equation leads to a true statement such as 0 equals 0, or 5 equals 5, or 10 equals 10, the equation is an identity. The solution set is all real numbers. If solving an equation leads to a single solution such as x equals 3, the equation is conditional. Its solution set consists of a single element, whatever that solution is. 3. If solving a linear equation leads to a false statement, such as negative 3 equals 7, 2 equals 5, things that are clearly false, then the equation is known as a contradiction, and we have no solution. A formula is an example of a linear equation, an equation involving letters. This is the formula for simple interest. We have I is the interest equals PRT, where P represents the variable for dollars or the principal, R is our annual interest rate, and T is the time. This time is always in years. So if I were to solve for T in this literal equation, interest equals principal times rate times time, my goal is to isolate the T on one side. So I can start by dividing both sides by PR, and this will simplify the PRs. Now we have I divided by PR equals T, or we can simplify it as T equals I divided by PR, and this is the formula to find the time for simple interest. This formula gives the future value or maturity value A of P dollars invested for time T at an annual simple interest rate of R. We have A is the amount that we will have after the maturity rate. P is the principal again, and we're going to multiply by 1 plus RT. This is going to allow us to calculate the future value of our money if we invest it now for a given time. Now let's try a question where we want to solve for P. Here we have A minus P equals PRT, and we are trying to solve for the P. Now notice that there's two P's in this equation. Let's add the P to both sides of the equation. This results in A equals P plus PRT, and now I need to figure out some way to combine these two. So we're going to actually factor out the P. I have A equals P times the quantity 1 plus RT using factoring. And now I could solve for P by dividing both sides by 1 plus RT. Let's divide both sides by 1 plus RT. If I divide both sides by 1 plus RT, we get A over 1 plus RT equals P, or P equals A over 1 plus RT. And that's the solution for our principal. If we were looking for the principal, we would be able to find it now. In part C, we want to solve for x. So let's start by distributing the 3 into the equation. This simplifies as 6x minus 15a plus 4b equals 4x minus 2. I can now collect like terms if possible. On the left side, I can't seem to add anything together. On the right, I can't seem to add anything together. They're all different letters. So we need to isolate the x. Let's subtract the 4x to both sides first. And this gives me 2x minus 15a plus 4b equals negative 2. Now we have a problem here. The negative 15a plus 4b is on the left side, so let's add 15a to both sides. I'm going to add 15a to both sides. And I'm going to also subtract 4b to both sides. This simplifies our equation as 2x equals 15a minus 4b minus 2. And finally, I can divide everything by 2 now, both sides by 2, and we have our solution. X is equal to 15a minus 4b minus 2. All of that is over 2. This is our solution now. Example 5. A woman borrowed $5,240 for new furniture. She will pay it off in 11 months at an annual interest rate, simple interest rate that is, of 4.5%. How much interest will she pay? First, we have the formula I equals PRT, and we'll have to plug in the values that we do know. We know the principal is $5,240. It's given here. And we know the interest rate is 4.5%, but make sure to convert this to a decimal. So I'm going to use 0.045 because the interest rate has to be in a decimal. The time has to be in years, and 11 months has to be converted to years. So 11 months is 11 out of 12 years. So 11 out of 12 years is equivalent to months. And now I can plug the values into the formula. We have the interest is equal to 5,240 times the rate, 0.045, and then we'll multiply by the time, 11 over 12. I would recommend leaving it as a fraction, so we can just type the whole thing into our calculator. And our answer comes out to be $216.15. This woman's going to have an interest of $216.15.